There is a discovery made in 1831 that produces essentially all of the electricity on this planet. Every power station, every wind turbine, every generator, every alternator in every car. All of it is one idea, and you can hold a working version of it in your hand for $5. To honest things before we go further, because I am not going to spring either on you halfway through. The first is that the output is genuinely small. Shaking a magnet through a coil produces electricity, and it produces a very modest amount of it. This is a light in your hand and a demonstration on your bench. It is not a power source, and it will not charge your phone in any useful time. The second is that if you build one, the magnet is the dangerous part, not the electricity. That sounds backwards, and it is not, and I will explain properly later, because people have been seriously injured by exactly the magnets this needs. And one more thing I will come back to at the end. The man who discovered this had almost no formal education, was working as a bookbinder's apprentice, and taught himself science from the books he was binding. What he did with the discovery afterwards is, I think, the most interesting part of the whole story. Let me start with the idea itself, because it is one of those things that sounds too simple to be the foundation of the modern world. Move a magnet near a coil of wire, and a current flows in the wire. That is it. That is the entire principle. Not touch it, not connect it. Move it. The magnet and the wire never make contact at any point, and there is nothing between them but air. The important word is move. A magnet sitting still next to a coil does absolutely nothing. Nothing flows, nothing happens. It is the changing of the magnetic field through that coil that pushes electrons along the wire. And the moment the movement stops, so does the current. Move it faster, and you get more. Use a stronger magnet, and you get more. Use more turns of wire in the coil, and you get more. Those three variables are the whole of it, and every generator ever built is an arrangement for maximizing all three. And here is the thing that genuinely reframes how you see the world once you notice it. Every power station on Earth is an elaborate machine for spinning a magnet past a coil. A coal station burns coal to boil water to make steam, to spin a turbine to turn a magnet past a coil. A nuclear station splits atoms to heat water to make steam, to spin a turbine to turn a magnet past a coil. A gas station, a hydroelectric dam, a wind turbine, the alternator charging your car battery right now, every one of them, the fuel changes, the method of spinning changes, the last step never does. There is exactly one common exception, which is the solar panel, and it works on a completely different principle. Everything else is Faraday. So when somebody talks about the energy transition, what they are largely describing is a change in what we use to turn the magnet. Now let me deal with the doubt some of you are sitting with, because it is the right question. You are thinking that if you could genuinely make electricity by shaking a magnet, everybody would be doing it, and there would be no need for power stations at all. That objection is exactly right, and the answer is the arithmetic. The energy you get out is the energy you put in with your arm, minus losses. There is no gain anywhere in the system. You are converting the motion of your hand into a small amount of electricity, and your hand is not a powerful engine. A person shaking a torch is putting in perhaps a fraction of a watt on average. And after the losses in the coil and the electronics, you are collecting less than that. So a minute of vigorous shaking typically gives you a few minutes of LED light. That is the honest figure, and it is what these devices are designed around, which sounds disappointing until you compare it against the thing it replaces, and then it becomes rather good, because every battery you own is dying right now, whether you use it or not. Go and open the drawer where you keep your torches. At least one of them is dead. There is a reasonable chance the alkaline cells in it have leaked and ruined the contacts, and the whole thing is scrapped. That is the failure mode of stored electricity. It degrades on the shelf, it leaks. And the one night you actually need it is the one night nobody has tested it. A shake torch cannot do that, because there is nothing in it to die. A magnet does not lose its magnetism sitting in a drawer. A coil of copper does not degrade. There is no chemistry anywhere in the device. So the honest position is that this is a poor power source and an excellent emergency light, and those are completely different jobs. Now, where this came from, because Faraday deserves more than a date, Michael Faraday was born in 1791 into genuine poverty in London. His father was a blacksmith in poor health, and the family often did not have enough. He had almost no formal schooling. At 14, he was apprenticed to a bookbinder. And this is where the story turns, because he did something remarkable with that job. He read the books he was binding. 7 years of binding books and reading them, in particular scientific works. Taught himself chemistry and physics from the pages passing through his hands. Then a customer gave him tickets to hear Humphrey Davy lecture at the Royal Institution. Davy was the most famous chemist in Britain at the time. Faraday attended, took extensive notes, bound those notes into a book, and sent it to Davy, asking for work. Davy eventually took him on, initially as a laboratory assistant, and Faraday went on to become one of the greatest experimental scientists in history. He discovered benzene. He worked out the laws of electrolysis. He built the first device that turned electricity into continuous rotation, which is the ancestor of every electric motor. And in 1831, he demonstrated electromagnetic induction, which is the thing this entire video is about. There is a story, possibly polished in the retelling, that a politician asked him what use it was, and he replied that one day the government would be able to tax it. Whether he said it or not, it turned out to be the most accurate prediction anybody made about the 19th century. Now, let me show you what is actually inside a shake torch, because it is almost absurdly simple. There is a clear tube. Inside it is a cylindrical neodymium magnet, free to slide from one end to the other. Wrapped around the middle of that tube is a coil of fine enameled copper wire with a great many turns. At each end of the tube, there is usually a stop, sometimes a spring, to stop the magnet hammering into the ends. Then a bridge rectifier, which is for small diodes, and I will explain why in a moment, which fills up over many strokes and then discharges smoothly into the LED afterwards. Trickle in, store, release steadily. That is the architecture of essentially every low-power harvesting device on Earth. And it is the same arrangement used in the other trickle sources I have covered, which raises the point that matters for anyone considering buying one, and it is worth knowing before you spend money. A great many cheap shake torches sold online are not shake torches at all. They contain a small rechargeable battery, an LED, and a magnet that does nothing except rattle convincingly. They are sold as shake-powered. They charge from a socket, and the magnet is decoration. The way to tell is simple. A genuine one has a visible coil wrapped around the tube, and you can usually see it. A fake one has a magnet rattling in an empty tube and a charging port. And the honest test is to shake it hard for a full minute after it has been sitting unused for a month. A real one will produce light. A fake one will produce nothing because its battery went flat in the drawer, which is the exact failure this device is supposed to prevent. Now, if you want to build one yourself, and it is a genuinely good project, here is what you need. A clear tube, which can be an acrylic tube or a thick pen barrel, a neodymium magnet that slides freely inside it, and more on those in the safety section, enameled copper wire, and the thinner the better, because you want a great many turns. Several hundred turns is not excessive. This is the tedious part of the build, and it is the part that determines your output. For small diodes for the rectifier, which cost pennies, a capacitor, or a small rechargeable cell, and an LED, total cost lands somewhere around $5 to $15, depending on what you have. To build tips that decide whether it works, wind the coil tightly and neatly, all in the same direction, in a band around the middle of the tube. Turns wound in opposite directions cancel each other out. And a messy coil is the single most common reason a homemade one produces almost nothing. And use the strongest magnet that will slide freely. Fit matters, a magnet that is to loose wobbles rather than passing cleanly through the field of the coil, and one that is too tight will not slide at all. Now the safety section, and I said the magnet was the dangerous part rather than the electricity, and I meant it. The electricity here is trivial, a few volts at very low current, and there is no shock hazard of any kind. Neodymium magnets are a completely different matter, and they deserve real respect. They are far stronger than people expect. Two of them approaching each other will snap together with genuine force, and fingers caught between them get pinched severely. That is not a theoretical warning. It is a common injury with these magnets. They are brittle. When they slam together, they can shatter, and they throw sharp fragments at speed. Eye protection when handling them is sensible. They damage things. Keep them away from cards with magnetic strips, mechanical watches, hard drives, and pacemakers. That last one is not a joke, and it matters if anybody in your household has an implanted device. And here is the one that matters most, and is the least obvious. If a child swallows more than one of these, it is a genuine medical emergency. Magnets in different loops of intestine attract each other through the tissue, clamp together, and cut off the blood supply. This has caused serious injury and required surgery in a great many documented cases, and it is why these magnets have been the subject of safety regulation in several countries. So if there are small children in your house, either do not build this or make it genuinely sealed, and keep loose magnets locked away entirely. Now the honest limits, all of them. The output is small, and I have given you the figure. Minutes of light for a minute of shaking. It is slow. Getting usable light takes a sustained effort. And in an emergency at 3 in the morning, that effort is not nothing. The LED is dim compared with a modern battery torch because the power available simply is not there. The winding is tedious if you build your own, and it is the part most people abandon. And a cheap commercial one may well be fake, for the reason I gave you. So who is this actually for? If you want a light that will work after 5 years in a drawer with no maintenance, this is one of very few devices that genuinely delivers that. It belongs in a car, a boat, a workshop, a bag, or an emergency box, alongside rather than instead of a proper torch. If you want to understand how electricity is generated, this is the best demonstration in existence, because it is the actual mechanism rather than an analogy. What you are holding is a power station with the fuel, the turbine, and the housing removed. And if you want light for a power cut, a modern rechargeable torch will outperform this comprehensively for the first several hours. The shake torch wins on day 4, so this week, here's what I would do. First, go and check your torches. Actually check them, open the drawer, press the buttons, and look at the battery contacts for corrosion. I suspect at least one is dead, and I suspect you did not know. Second, if you own a shake torch, shake it hard for a full minute and see whether it lights. If it does not, look for a charging port, because you probably own a fake one, and it is worth knowing. Third, if you build one, wind the coil first in one sitting, because that is the part that ends most projects. And fourth, if you have neodymium magnets in the house and small children, go and find out where those magnets are right now. Tell me in the comments whether your torch drawer passed the test, because I would genuinely like to know what proportion of them are dead. I read every one of these. Here's the thing worth keeping from all of it. A bookbinder's apprentice with no formal education read the books he was binding, wrote to a famous chemist asking for work, and in 1831 demonstrated that moving a magnet past a coil of wire produces electricity. Almost every watt of power in the modern world still comes from that single observation. The fuel we burn to do it has changed several times, and the last step never has. And you can hold it in your hand for $5 and feel it work, and there is nothing hidden inside it. That is not a lost technology or a suppressed one. It is the opposite. It is the most successful discovery in the history of engineering, so completely absorbed into everything around us that almost nobody remembers there was a moment when somebody found it.